Welcome again, everybody. For those of you who couldn't join us 2 weeks ago, my name is Rebecca Poole, and I am CNYC's Director of Membership and Communication. This is the second class in our 4-part Local Law 97 series. As with the last session, we're going to ask you to put your questions for us in the Q&A. We have an engineer from RAND, Jishnu Mehdi, with us online tonight to answer and direct questions to our speakers as needed. If there's time at the end, we will try and answer unanswered questions live. If not, we are keeping a log of all questions. So if you don't get an answer this evening, we'll make sure you get one as soon as we can. We are also grateful to have Selena Josephs from 32BJ here with us this evening to handle our tech for us. As you can see, for our third class, we have 3 breakout rooms for you to visit. In the first room, we're going to have a solar installation case study. In the second room, we're going to have a heat pump case study. And in the third room, we're going to have case studies of smaller projects that optimized heating and electrical plants. There's some more information coming on what will be in those rooms, but at the end, you're going to receive a survey. If you could please answer it and rank your choice, because we're going to try and get it so that you can actually ask questions in a meeting format, but we'll need people to choose the breakout room so that we can do that evenly. Without further ado, it's my honor to introduce Marianne Rothman, the Executive Director of CNYC, who will introduce our speakers for this evening.
Thank you, Rebecca. Peter Varsalona is Principal and Vice President at RAND Engineering and Architecture, where he heads the firm's building design group, focusing on multi-team, large-scale projects. He has extensive experience managing the design and upgrade of building envelope and major building-wide systems. Peter has prepared dozens of plans and specifications for large-scale system upgrades, including heating and cooling plants, gas and water piping, oil-to-gas conversions, electrical wiring and metering, fire protection, roofing replacement, and exterior facade repairs and restoration. Peter is also the president of the Council of New York Cooperatives and Condominiums Executive Board and serves on the board of the co-op where he lives. He's spoken and written on building design and performance for a number of industry groups, has been quoted for his building expertise in the New York Times and other publications, and has appeared on New York One's Real Estate Report. Mr. Varsalona received his Bachelor of Science in Mechanical Engineering from Columbia University. He's a licensed professional engineer in New York, New Jersey, Connecticut, and Pennsylvania, as well as a certified energy manager, a certified building commissioning professional, and a certified New York State asbestos inspector, management planner, and project design. His cohort, Dennis DePaola, is the Executive Vice President and Director of Compliance for ORSID New York. Dennis leads ORSID's compliance department, and as an attorney, he's also the firm's corporation counsel. He received a BS in business management from Lemoyne College in Syracuse and a Juris Doctorate from St. John's University School of Law. Dennis draws on his background to advise ORSID's clients on the myriad rules and regulations and codes that affect their properties on a day-to-day basis, helping devise compliance strategies that make sense from a business and residential perspective. Gentlemen, the floor is yours.
Thank you.
Thank you very much, Marianne. And hello, everyone. Let's just start off with a little bit about RAND and ORSID. RAND is a full-service engineering firm. We handle all types of engineering and architecture projects. We're not affiliated with any contractors, but we're well suited and been around in the co-op condominium industry for many years now in New York City. Dennis, maybe a few words about ORSID.
Sure. ORSID, we've been in business now in third generation since 1955. We manage approximately 200 co-ops and condominiums throughout New York City, about 24,000 apartments, and we have a full range of management services, as you can see on the slide. We can help you through all the different compliance aspects that are facing all New York City buildings. So I'm going to handle the first portion of the presentation which is really just laying the groundwork. Before we get to the potential pathways for compliance, we really have to understand the Climate Mobilization Act's requirements and how it affects different buildings and how it dovetails with all the other environmental laws in New York City. Some of this might be duplicative of your last session, so I apologize for that. But again, it's very important that we lay the groundwork before we talk about the potential pathways. So Local Law 97 of 2019, the Climate Mobilization Act, is the most ambitious carbon reduction measure in the world. It aims to reduce citywide greenhouse gas emissions by setting strict emission caps on larger residential and commercial buildings. By larger, we mean buildings that are over 25,000 square feet, which actually is not that big. You could have a small 6-story building that would be over 25,000 square feet. Also applies to 2 or more buildings on the same tax lot that together exceed 50,000 square feet, or 2 or more condominium buildings governed by the same board of managers that exceed 50,000 square feet. The important dates to remember are, one, the initial compliance period of 2024 to 2029. In just 3 months, all the buildings that are affected will be on the clock, meaning their energy consumption will count towards the emissions caps for this first period of 2024 to 2029. Then the subsequent compliance period, 2030 to 24, comes into effect, and further compliance periods as we go out through 2050, the rules of which have not yet been finalized. But again, the first compliance report, which is the benchmarking date for the calendar year 2024, has to be benchmarked by May 1, 2025. And then we'll have ongoing filings thereafter. Again, starting in 2024, buildings that are subject to the law must have their annual emission intensity limits certified. And the emission limits are defined in metric tons of carbon dioxide per square foot. Mixed-use buildings where you have residential and other types of uses, say retail, professional spaces, schools, all must enter those into the benchmarking EPA energy software. These must be certified by a registered design professional who's preparing the emissions report. The EPA portfolio manager software has about 60 different use types with differing carbon emission limits that are available. And the rules have the different carbon intensities for each of these use types. So it's very important that each of these use types be measured and the entire building as a whole be measured by a registered design professional as soon as possible, and much sooner than May 2025. The reason for this is we really need to know what the carbon emission cap will be for your specific building, and that will depend again on the differing use types. We're trying to have all of our buildings measured now in 2023 so that we can best advise our boards what their actual penalties would be if they don't do anything under the law. So the building's annual emissions are determined by combining the total energy used for each fuel type, whether it be gas, electric, steam, oil, multiplied by the corresponding carbon coefficient as set forth in the law. The carbon from electricity used by buildings will go down as we go out further to 2050. Local Law 97's carbon coefficient for 2030 compliance period is about 50% cleaner than the one assigned for the first time period of 2024 to 2029. So emissions due to electricity gets halved. This is largely because under the Climate Leadership Protection Act of 2019, 70% of the electricity generated in New York is to be from renewable sources by 2030. And the New York electric grid is scheduled to be net zero by 2050. This is why you see the main path of compliance that we'll be talking about is trying to electrify items that are currently under fossil fuels, and moving to electric will really reduce or minimize the carbon footprint of the building. As you can see here, this is an excerpt from the law with the carbon emission caps for multifamily housing. This is one of the 60 use types under the law. And again, there's different carbon emission caps for those different uses. For instance, supermarkets and food preparation have a much greater carbon allowance than would a doctor's office or multifamily housing. So as you can see here, in 2024, the carbon emission limit of which is again in TCO the TCO per square foot is 0.00675, which drops precipitously in 2030 by 50%. Then further compliance periods out in 2035, it goes down to 60% of the 2024 period, and then 2040 down 70% from the initial period. And again, going out to 2050, there is a net zero applied to all use types, all property types. So that's where the buildings are expected to be carbon neutral. Along with the implementing energy saving measures, building owners can meet their emissions by various other methods. We're not going to talk too much about these because the rules aren't yet finalized, but the law does allow for purchasing greenhouse offsets or renewable energy credits, carbon emissions trading, generating or storing clean distributed energy resources such as solar or battery. The renewable energy credits that are being discussed, the preliminary rules are out and really can only be used to offset electric carbon offsets. So it's limited utility where you have buildings that are heavy fossil fuel users. For instance, if you're burning natural gas year round for cooling and heating in the winter, those renewable energy credits would not be available to offset that carbon emissions. Again, the very first compliance report is due by May 1, 2025 with the benchmarking, with filings due every May 1 thereafter. And the compliance report under the Climate Mobilization Act must be certified by a registered design professional and state whether or not the building was in compliance for the previous calendar year, and if not, list the amount by which the building exceeds the limits. Extensions may be granted if the building owner is unable to file on time despite documented good faith efforts. The penalties for noncompliance are very steep. As I initially stated, the Climate Mobilization Act is the largest and heaviest undertaking in the world to reduce carbon emissions, and that's verified by the $268 per metric ton penalty, which is the most expensive carbon pricing in the world. For owners of buildings that exceed their annual emissions limit, the law establishes the penalty based upon the difference between the reported emissions and the annual emissions limit multiplied by that $268 per ton. And additionally, failure to file the annual report within 60 days of the deadline could result in a violation with a penalty of 50 cents per square foot of the gross floor area. For a minimally sized building of 20,000 square feet, 25,000 square feet, that would be a minimum penalty of $12,500 per month for a property that fails to file. And further, making a false statement on a report is a misdemeanor crime, and it will carry a penalty of $500,000 or imprisonment. So this is not something that can be taken lightly, and we can't really fudge these reports. There's going to be serious ramifications for anybody who does. So Local Law 97, the Climate Mobilization Act, is related to many other environmental statutes, some of which came under the city's Greater Greener Buildings Plan of 2009, where we have the benchmarking laws, which includes Local Law 87 of 2009, energy audits and retro commissioning reports, which we just finished the first 10-year cycle for Local Law 87, and we've just started 2023 as the first year of the second cycle, 10-year cycle. We also have, as you know, you see energy efficiency grades on the front of your buildings. The city has assigned a letter grade that's under Local Law 33 of 2018 to try to shame buildings into reducing their carbon emissions. And of course, the Climate Mobilization Act, which we're here to talk about tonight, includes several aspects. Local Laws 92 and 94, which requires roofs of certain buildings to be covered by green roofs or solar systems. Peter and I were talking about that briefly and how it doesn't apply to many of the roof work jobs that you would do to reskin your roof to put in a new waterproofing membrane. This requirement for green roofs and solar systems would really be if you're structurally taking out the slab and going from there. So that's why you haven't been seeing a lot of these green roofs, other than people who wanted to be more energy efficient, they haven't been required to do so in most instances under Local Law 92 and 94. Again, Local Law 95 assigns the building energy efficiency grade, which we discussed. Local Law 96 establishes a sustainable energy loan program for these measures. You may have heard of PACE financing, which is available to pay through the building's real estate taxes. Problem with that financing is most co-ops and some condos have underlying loans, and under the PACE program, those mortgage holders would need to subordinate their interest to the PACE loan. So not many buildings have really taken advantage of it because that is a very stringent requirement, and not many mortgage holders will subordinate their loan to a PACE loan. And again, we're discussing the Local 97 commitment to achieve reductions in greenhouse gases by 2050. One of the main roadmaps towards compliance with Local 97 comes from the Local 87 energy audits. And we're going to be looking in further slides at some sections of those of audits. These audits are critical in the process. The audit is an ASHRAE Level 2 audit, which is required again every 10 years under Local 87 for buildings over 50,000 square feet. But it's also needed for an effective analysis for Climate Mobilization Act in the determination of the potential conservation measures, the ECMs, regardless of a building size. Note that Local 97 applies to all buildings over 25,000 square feet, and so many building owners need to invest in their audit regardless of whether or not it's required under Local 87. And you need this to accurately calculate not only your penalties, but your potential pathways to compliance. So the objectives and methodology of the Local 87 energy audits should include the following: analysis of the historical energy consumption data to identify types and costs of energy use at the building, a determination of the existing conditions that are consuming energy, the evaluation of how energy is being used and probably wasted, the development and performance targets for the base building, identification and analysis of energy efficient measures for improving operational techniques and or equipment to reduce energy costs. That's a big item that Peter will be touching on later on, how the operations and maintenance of the building, your building staff and how they operate can really go a long way to increasing your energy efficiency and reducing your carbon footprint and penalties. The report should also include a performance of economic analysis of potential measures to determine the cost effectiveness, and we'll be looking at a sample in a subsequent slide, and also research for potential funding opportunities for these recommended measures. A good Local 87 report will talk about that in analyzing the cost-effective measures that you could undertake. Additionally, in order to accomplish these objectives, we should take the following measures: the collection and review of historical energy consumption data, visual observations of energy consuming systems and general site features, testing and measurement of building energy systems using the industry standard equipment, manual calculations showing interactive effects, interviews with building management, maintenance personnel, and residents, and discussions with responsible building trade contractors, cost estimating utilizing labor rates and material costs based on RS means cost data, and comparisons with similar buildings, and again, research for potential funding opportunities, which will largely impact the financial viability of these projects. This is an excerpt from a Local 87 report, and this is a table that you could hope to see. Many of our boards get these 200-page reports, and obviously their eyes glass over. There's a lot of dense material in here. But if you do get, and if you have the opportunity to review your Local 87 report, I encourage you to look for these tables. This is for energy conservation measures that the design professional has considered that the building could undertake. And as you can see, there's an estimated cost for each of them, potential energy and power savings, either in electric or gas, annual savings, what could be expected for reduced operational costs, as well as the simple payback for the investment. And over on the right-hand side, you can see many of these measures have a very short payback period. These include common areas measures, which are easier for a board to undertake, obviously, if the finances are there, if the funds are there, but also potentially measures within the apartments that could be done either on a building-wide basis or upon alteration or unit by unit over time. This slide is something you would expect to see in every Local 87 report as well. This is the retro commissioning portion of the report. And this is the minimal required work that needs to be done when you file your Local 87 work. You have to do basic, again, minimal operational changes. A lot of times what we see here is pipe insulation, replacement of valves, and traps, things that are necessary to have the systems work as they were designed to and minimize inefficiencies in their operation. So again, if you are looking at a Local 87 report, I greatly encourage you to look for these tables. Sort of the low-hanging fruit. These are the minimal items that you need to get done right away, but the energy conservation table as well is the first step in your potential pathways to compliance with the Climate Mobilization Act.
Thank you, Dennis. So how do we approach this? And I think first is figure out where you are, right? Use your Local Law 97 calculator. Building Energy Exchange has an excellent one. We'll take a look at it as well tonight. But you got to calculate your carbon emissions, right? So you got to benchmark your building, right? Take multiple years of past energy usage and consumption. You look up anything that you use to generate energy, and you compare that to the Local 97 thresholds that Dennis was talking about. You do the calculation, you see where you stand, right? Not every building's going to be the same, right? There's going to be a lot of different variants in how much reduction you need to achieve for compliance at different periods of time. The approach has to be taken as an understanding of it's not a one-time, I comply 2024 and okay, I don't comply by 2030. I'm going to do something to get there. And then what am I going to do in 2034 and 2040 and 2050? Everything's got to get to that net zero compliance. And the penalties don't just go away, right? They're still there. And you have to have both a short and long-term approach, in my opinion. And part of that is dovetailing your Local 97 evaluation with your capital improvement plan. And we'll talk a little bit about capital improvement plans. But essentially, you need to figure out at the end of the day, what is going to be the pathway to compliance. And it could be, again, a moderate reduction that's needed, where you're moderating shareholder measures or base building measures, maybe trying to just achieve a 5 or 10% reduction, depending on where you stand currently. You could also require something a little bit more significant, maybe some deep base building measures that require 10 to 25% reduction. Now you got to get into some much more significant capital improvement type work, greater than 25%, and we have co-ops and condominiums in that category, where they got to do substantial work to achieve compliance, and that's going to be a tougher road for building over the next 2 decades to figure out what is that solution. As Dennis mentioned, for buildings over 50,000 square feet, you got to do an audit per Local 87. But energy audits have been around for a long time. They're a great and useful tool. Any building that has to approach Local 97 needs to do some type of auditing. I know you can just use the benchmarking data to figure out where you stand from a threshold perspective, but that's not enough. That just gives you kind of where you stand. You need to determine what are those energy conservation measures, and well beyond the standard ones that we've already been doing for the past 10 years. We've already been insulating piping. We've been putting in LEDs. Like, you need to do something much more substantial to reduce your reliance on fossil fuels. It's electrification and insulation. Just repeat those 2 words over and over. How do you get those things implemented in your capital improvement plan? So what are the main traditional ways to compliance? Space heating electrification, right? That's a big one. Very challenging for buildings, owners who are in pre-wars with steam systems. Not that easy to achieve, right? It requires really substantial work to do something like that. But if you have a more, a post-war construction or something more modern or newer, you have a greater chance of electrifying systems more readily. Doesn't mean it's cheap and easy. It requires quite a bit of investment, but that's the largest type of reduction you could see in your greenhouse gas emissions. In a similar way, domestic hot water electrification is another very useful pathway. We're incorporating it in a lot of our heating plant upgrade projects where even if you're maintaining a gas-fired system for the near term, we're electrifying the domestic hot water generation. You could see fairly substantive reductions, not just in energy use, but in greenhouse gas emissions resulting from that. It's not a one-fit-all solution. It's part of a fabric of different things you need to do to reduce your reliance, to reduce your energy consumption and ultimately your greenhouse gas emissions. Wall insulation. Most buildings don't have it, right? If you're in a pre-war, there's no insulation. It's the brick, terracotta. Maybe they slapped on a black painted vapor barrier in the 20s, and then as plaster. There's no insulation whatsoever. So obviously, wall insulation is a benefit, or you can really reduce your heat loss through exterior walls. You can incorporate it into your renovation alteration requirements, requiring, when someone renovates, you fur out the walls, you put insulation in. In some cases, you insulate on the outside. If you have a post-war construction, I know of several buildings that have white glazed brick. We know the problems with white glazed brick, right? Brick starts to spoil over time. Instead of just skinning the building and putting another brick back, they've put up, insulated rain screen systems. Really changes the look of the building, but you really are addressing a significant energy need, and you're solving your capital improvement problem in a different way, something you would have had to have done in any event as part of your capital planning or capital improvement plan. Common area lighting, many of us have already done things of that nature. Again, still I survey many buildings still with old lighting. Roof insulation is a big item. We get a lot of losses, convection and conductive losses through a roof, primarily conductive losses through the top of a building. Heat rises, you lose the heat through the upper section of that building. Conversely, roofs can take on, even those that are coated, can still take on a lot of heat energy. Installing roof insulation can have a real big benefit to reducing the amount, your ultimately how much energy you're producing on site to heat that building. Key notes that there's challenges with that. If you have old roofing systems and you have to now comply with energy code, the insulation thickness can be quite significant. We're going to look at some product that tries to combat that issue. The thicker the insulation, it affects parapet heights. You have minimum 42-inch parapet height requirement. All of a sudden now you got to put in side-mounted railings because the roof thickness is too great and reduced your parapet height. You got thresholds at bulkheads and stairs that can be impacted. So it's not so easy to implement, and it's case by case. But if you're in a building, let's say that is not subject to the energy code, it's a contributing building, or it's on the state or federal registry and doesn't have to comply with energy code, you may choose to do so because it has an energy benefit to you. Solar array, again, it depends on your type of building. If you're in a larger complex or you have a very large roof area that you can work from, this can be very beneficial. For most of us that have built smaller footprints, it's somewhat more limited. Capital plan. So it starts, to me, once you have that basic information on your thresholds for 97, you now need to then see, okay, well, where do I stand? What kind of reductions do I need to do? And the best part is well, okay, if I have certain pathways to compliance, how do I carry that into my normal 10-year or 15-year capital plan? And this is an example capital plan. You see these all the time where there's mandatory and discretionary work requirements. It includes every kind of component in a building, whether it's the facade, right? We all have FISP. If you're in a building greater than 6 floors, you're going to have to go through FISP every 5 years. Those programs can be quite substantive depending on the amount of work you've done in prior cycles. Gas infrastructure. Gas piping is another whole animal. If you're doing your local 152 inspections now, obviously you're looking at exposed gas piping. But if you're in an older building, these gas pipe systems are antiquated. And when they fail, often they fail catastrophically, and it takes a long time, and it can be quite expensive to reestablish gas service. Might be a time to incorporate an electrification upgrade where you would consider electric stoves or induction ovens. Not for everybody. Okay, there's a lot of strong discussions about gas versus electric, but I can tell you that that is something that has to be at least considered. You have plumbing systems, insulation. Owners don't sometimes realize that you are required to insulate piping, even piping that has been exposed during renovations. It's a retroactive requirement in the maintenance code that you really need to implement. It's important to maintain insulation on pipe systems. You want to try to comply with the latest code. Windows, obvious item. Unfortunately, windows are many times left to the discretion of a shareholder, or it's passed on to their requirement. So in many cases, it's limited to what you can insist on, unless you're a co-op that covers windows and window replacements. Discretionary items, we mentioned roof replacement. You can see on this particular table, it's $1 million in year 2027. Well, if I'm planning for that, I'm going to make sure that I'm going to reevaluate what is my insulation thickness now, and what can it be, and what are the benefits of that? What energy reduction would I expect to get from that specific component, or what kind of greenhouse gas emission reduction would I achieve from doing that, compared to the extra cost? Right, I'm already planning to spend $1 million for this roof. Maybe the extra insulation only adds a small amount of extra cost to that, and I gain the extra energy benefit. So that's kind of the analysis you need to do for component to component. Domestic hot water, electrifying, we mentioned that is a big item that's often looked at for co-ops who need the modest reduction to try to achieve that as part of the formula to get there. Space heat electrification. Sure. Go ahead.
Yeah, if I could just jump in on this slide. This is actually from an ORSID building that we put together. What I would want to point out is this is a living document. This is not just something that's adopted and then enacted over the 5 or 10 year period. You got to look at this each and every year. And there'd be different measures used for different compliance periods. This is designed to get under the 2024 threshold by installing this electric domestic hot water heater in 2024, and then that would cover them for that period. Additional items may come on this report, may come on in this plan as the different components of the building outlive their useful life. For instance, the elevators, et cetera. So again, you want to be looking at this each and every year. And if you look at the bottom, we put in various different sources for the funds. Obviously, not every building has a $10 million reserve fund that's going to just fund all these measures. No, you have to consider where the money is going to come from. And it's not necessarily one place. It could be additional debt from refinancing. When the building's mortgage comes due in 2027, you'll see an assessment at the bottom too for ongoing capital needs of the building. We'll also be looking at this. These projects are net costs. So if there was financing available for any one of these projects, it would be considered here as well. But again, it's important that this is a living document, and you look at this at least once a year, if not more, and look at the different compliance periods and when developing your potential pathway to compliance with the Climate Mobilization Act.
Those are great points. I think the one critical point is that this is, you see that word draft? That draft stays there forever, right? This is never issued. It's never final. It's not something that, a lot of co-op owners or boards will want to see in an annual report. It's a working tool document. It's something that you're constantly reviewing through, and like I said, through the eyes of Local 97, now every component has to be reviewed for any kind of reduction you can achieve. So it's a constant tool that you use and update to see where you stand. We mentioned space heating electrification as probably the largest source of greenhouse gas emissions you can have in a multifamily building. It's an opportunity for very substantive reductions. And newer systems, they tend to have more thermal comfort and control given than compared to, let's say, older legacy systems. We're seeing more and more heat pump systems being implemented as replacement alternatives to a traditional steam or hydronic system. You'll see master plans developed by owners who will incorporate rooftop space. They'll include in their capital plan the installation of, let's say, steel dunnage. They'll include electrical upgrading options for shareholders or unit owners in the future. And then they will stand back and say, okay, as owners want, they will, install these types of systems. Other owners are continuing all the way through. They're installing the refrigerant tubing, they're installing the electrical conduit, they're installing the condensers, they're doing everything they have to get off of the fossil fuel burning system. And at that point, they're also putting in, let's say, a heat pump, water heater, or incorporating some type of electrified domestic hot water production. Those programs take time, they're expensive to implement, but when you compare it to, let's say, and I have a slide later on that compares a steam system upgrade to a VRF, let's say, system. Then maybe the initial capital investment is significant, but now when you have to start incorporating the review of the fines that are potentially levied against you for not complying, and also there's quite a few incentive programs through utilities and tax credits available to help bridge that gap, to make it more palatable to make that call. I know that can be a very difficult decision to make for boards. You're looking for payback periods. The problem with payback periods is that you're now influenced by local 97 penalties, right? So that skews the analysis. Normally, when you're comparing two mechanical systems with different life cycles, you would use a uniform annual cost method to analyze, which one is better from an engineering economics perspective. But now the whole analysis is a bit skewed, and because of the penalties, you have to incorporate the review of potential penalties associated with maintaining a specific type of system compared to one that offers you a reduction or an electrified system, for instance. Choosing the right solution, again, all depends on your type of building. This is where you really need to lean on the licensed design professional or consultant who's evaluating this on your behalf. We mentioned what are some of these. You can see from photo, traditional VRF systems. These often get installed on roofs. There's the indoor units are separated from these outdoor heat pump or condensing units. VRF is very commonly used in multifamily housing as well as commercial applications. They're very efficient types of systems. You will see mini split systems or air source heat pump systems. Tends to be more traditional one-to-one that replaces, let's say, an window air conditioner or a localized heating system. All of them tend to be very easy to control. They're efficient. They're generally quiet and very suitable for individual apartments. You can also incorporate a package terminal heat pump. These combine kind of the outdoor and indoor component into one. It tends to be a through-wall unit or perhaps through a louver or window. There are alternatives to these as well. And you're going to see more and more products on the market that are going to incorporate kind of systems that will allow you to utilize existing sleeves, or perhaps maybe a slightly larger sleeve compared to maybe a smaller through-wall air conditioner, but something that could be readily adopted. The key is evaluating, when you're dealing with point source systems, what kind of power is needed. Do you have enough power from your individual panel to those units? Do you need to upgrade service to your power panel in order to incorporate the upgrade? And those are things that can add cost and need to be. It's beneficial if you're evaluating that on a building-wide basis, and then you can educate your shareholders as to what's available to them. We mentioned domestic hot water electrification. Again, another common type of upgrade. There's more and more equipment manufacturers generating different types of electrified systems. I mentioned a heat pump type of water heater. There are, ones that can connect to multiple domestic hot water storage tanks. They can be very modular in their design to incorporate different load characteristics. You could have storage tanks that really can be, can really be effective measures for energy storage. Cost efficiency varies between them. You obviously want to try to find that type of system or systems that work best for you, that provide you with the best return on investment. Obviously, for full electrification, as opposed to, let's say, a mix of gas and electric, you're gaining the best benefit of that. They can be expensive. And right now, some of the equipment is very expensive if you have a fairly large load. So you have to be careful in your analysis of what kind of system works for you. And is this the best type of energy conservation measure to get you where you need to be, right? It's one of many options. You'll have to decide financially if it works for you and if this is the way you want to go. We mentioned to some others, electric resistance water heaters is the more traditional type of water heaters that can be bundled together. We often see these for, let's say, summertime use, that rather than turn, let's say, a larger boiler that may have an indirect or direct means of generating domestic hot water. This could be used during the summer months. In some cases, you can incorporate it to use all year round. These tend to be less efficient than the newer heat pump water heaters, but again, it has to be considered in comparison to all of your options. One of the things that you look at is that this slide shows 5 different types of water heating capability. Not everything has to be done at one time. Again, it can be gradually implemented in a building. You could start off with something that is, more in terms of electric storage or resistance heating that's more traditional. Obviously, the tank does require some more space than, let's say, an instantaneous heater, but it can be installed indoors or outdoors. The electric heat pump options are split type systems. They include tanks that are indoors, compressor outdoors. Indoor units do require ducted ventilation, so that may add a little cost. But still, you still have instantaneous gas and storage gas units, storage tank gas units that can be implemented now, and they will accommodate you until you get to where you need to be, let's say in 2034, where maybe that's the time when you would implement, let's say, a heat pump with a solar heating component that you can then implement. You've planned for, you've done your roof replacement in your capital plan, and now this is the discretionary item that gets you to where you need to be with in terms of reductions on energy cost, and of course any penalties that would be applicable at that time. We mentioned wall insulation. Wall insulation is, again, there's different options. We mentioned interior and exterior. They have a lot of different benefits. For obviously, if you're doing a renovation, very easy to incorporate. If you have an existing apartment, it can be very difficult to implement. You don't want to lose finishes and floor space. A lot of buildings are incorporating exterior wall type rain screen systems or EFIS systems. These systems have been engineered and designed to really provide great reduction, great thermal benefits. They're very durable. They can be quite beautiful to change, let's say, a building facade that's starting to look somewhat aged. And they're allowed by zoning. They're incorporated more and more into building designs, and it's something that can also facilitate compliance. Where, let's say, if you're anticipating a very expensive brick or masonry repair program as part of FISP, this type of, even though it's a large investment to install a rain screen, it counters the cost that you would have had to have spent if you were doing a significant skinning or repair of the facade. And it also, now you've gained the thermal benefit associated with that type of installation. Again, rain screens again come in many different options. This is just a visual of the different components that would comprise it. And this would go over an existing installation. For newer buildings, it's incorporated obviously into the building design. And you get pretty substantive, reductions. Wall insulation, in this, on the right, you'll see a graph that shows the different reductions of source energy, or savings, I should say, for source energy use, as you employ different retrofits. And wall insulation, you can see, quite a significant reduction is achievable. Common area lighting. Many buildings have already incorporated this, but buildings that are just over 25,000 square feet that weren't really doing an energy audit, right? The buildings between 25,000 and 50,000 square feet that didn't do an audit, but have to comply with 97, they may have a lot of cases where they have an upgraded common area lighting. So this is one of those things that you need to review. In the first class, there was a lot of discussion about local 88 compliance, so I don't want to talk much about it, but essentially you got to upgrade, not only all your lighting to LEDs, and you need to sub-meter. So if you have tenant spaces that are not metered, or if you have a master meter, you need to now break those up and meter tenant separately, meter each tenant. Roof insulation, we mentioned as a possible alternative. You get a lot of losses through the roof. Like we mentioned, there are some challenges, that can be difficult to implement. However, if you can overcome those challenges, you can really achieve pretty substantial thermal performance from the new system. And there's, depends on the roof work you're doing. So if you're at that time where you really need to do a full roof replacement, in New York City, you're allowed one cap sheet application on top of an existing roof. After that, you need to rip the roof up and bring it down to the decking and install new insulation and new roofing. If you have a concrete deck, you're installing above the deck. If you have a wood deck, there may be an opportunity to blow in insulation within a cock-off space, let's say between the top floor apartment ceiling and the decking of the roof itself. These are things that your consulting engineer or contractor would review, and the energy code kind of defines what those requirements are. So you're looking for what kind of cost versus energy savings you achieve from doing that. What is the reduction in greenhouse gas emissions that you think you can get from reduced energy use resulting from that type of upgrade? And does it seem to make sense for the cost investment? As I said, if you're already planning a pretty significant roof replacement in your capital plan, incorporating this is not much of a delta on top of that. Often you see two types of systems, right? A modified bitumen system or a liquid applied roofing system. The liquid applied systems are more and more common because they don't use hot materials, kettles or torches. The biggest thing is the insulation, and we mentioned the uniform insulation, that requirement in the energy code. When you're dealing with an R33 roof or something that requires significant levels of insulation, you run into problems, right? Not every building can accommodate multiple inches of insulation in the roof system without affecting other systems. So there are some products around. You can now find more vacuum insulated panels that can be used to reduce the thickness. Like on the left, you see it's a lot thicker. However, it doesn't want to be penetrated, right? So you're paying more for that type of product. It has to be carefully laid out on a roof system. You can't penetrate it, but it may mitigate some of the issues you had with all the multiple layers of insulation you were trying to put into, although to achieve the goals of the reduction requirement. Solar, again, usually it's part of a roof upgrade, meaning that the roof itself has to be has to either be reinforced to accommodate the weight of the panels, or the roof itself is being upgraded and then the panels are incorporated into that upgrade. You do need a fairly large area to make it work. In this example here, let's say you have a 5,000 square foot roof, can use a 75 kW array, and that would save a little over 8,000 in penalties annually and 20,000 in energy costs. The system would cost around $136,000 after tax credits, so the payback's in that 4.5 to 5 year period. And we have some incentives that on another slide that we'll show. But again, it's, do you have that square footage available to you? Do you have, the capability of now bringing that, transmitting all that energy, the solar energy, down to equipment that can then be used inside the building? Or what is in your building that can be fed from this system? Because clearly it's not going to be able to feed apartment spaces. It's going to have to feed certain common and PL&P systems. How do you actually address that as part of the analysis? And again, it depends on the footprint, but there are a lot of systems. I know I mentioned solar heating with storage. Those can be very effective. But again, if you're dealing with a large multifamily property, it's very difficult to make those work. there's a lot of incentives. So, you can look at it. We have this on our website, but the lot of different tax abatements and credits are available with solar right now. So if you have the capability of it, you can make the finances work a little bit better than historically. It was sometimes very difficult to make the finances work. Green roofs, again, very effective in providing not just an additional insulation, but in a cooling effect. But it also helps with stormwater management. And as we get into heavier storms, where the intensity of rainfall has increased well beyond what building codes required, even today, for stormwater drainage systems, well, particularly in older buildings, those drains cannot accommodate the runoff. So if I'm able to put in a green roof system that can help with that, alleviate that strain on the drainage system, I also can get the benefit of that in addition to improvement on energy savings from the roof itself. Again, usually part of a roof upgrade, so that can be incorporated into the capital plan that you're developing. And it may even be one of those discretionary items. What's the additional? It doesn't also have to be the whole roof, right? It can be a portion of the roof. We mentioned, Dennis mentioned about local law 92 and 94, not usually applicable for most of our clients' buildings because you're not affecting the structure. But if you were, it would have to be done, and certainly if you're in a new building. Again, challenges, it can be expensive. They do require maintenance, right? The plants can die, so they have to be replanted continuously. They can't be neglected. It does add weight, so there's a structural component that has to be, incorporated into the plan. And not every roof, a lot of roofs incorporate individual terraces, so it doesn't always work for you. Again, more in terms of compliance pathways for sustainable roofing zones. This has to do with, this is just another example. You can see that, and this is taken right out of the buildings bulletin from 2019 that goes over the requirements. As I mentioned, most of you don't have to do this, but just to show you on the right, you can see, let's say you had a 15-watt solar capacity per square foot, and it was a minimum area for 4 kW, which is 270 per the requirement. You can see some of the reductions that you can achieve. It's not insignificant. So if you're someone planning a roof replacement in your capital plan and you don't need a greater than 25% reduction, this might be able to get you closer to compliance, at least initially. Of course, as time goes on, it has to be just one of many options in your overall plan. Energy management systems, very few of the buildings we survey incorporate these, particularly in co-op and condominium land. You can gain a lot of savings from this. And one of the things that, that owners often forget about, they're always thinking about capital improvements, major programs, but maintenance and monitoring of existing systems is critical. You can achieve significant savings in energy, for making sure your systems are operating at peak efficiency, that leaks are not left unnoticed or addressed, that you have systems in place that alert you immediately when things are not performing the way they should at set points that you've established. So it's really, these types of systems can really help your building staff and management personnel make sure that your systems are not wasting energy, particularly on the water side. Many times buildings don't realize how much water they're using. The more water you use, you have to heat that water. It's very expensive to heat water in the city. So again, energy management systems are something that you really can look into. They tend to be fast payback items, and they can really help as part of the overall formula for what you need to achieve compliance. We mentioned insulation. Again, we go into a lot of buildings that are terribly under insulated, pipelines that have very little insulation or missing. You want to make sure that those systems are insulated well. Obviously, if you still have a steam heating system, you want to make sure those are operating well. You don't want to be wasting energy from leaks or from faulty steam traps. Again, most of the regulations are pushing us an electrification option. So whatever we're doing on our steam system, we're maintaining it to give us time to get to where we need to ultimately. Air sealing is important. Losses through windows, vents, doors, vestibules are critical, and they really hurt you in your overall score. You really have to use a lot of energy to combat those infiltration losses. So if you can seal those up, it really helps reduce the amount of the time your boiler is ultimately operating. Aerators, low flow areas, and shower heads is so much water waste. Make sure that those are incorporated into all alteration agreements with shareholders. Traditional versus non-standard ECMs, you see a lot of, on the left, these are the common types of upgrades you'll often incorporate. If you haven't done so already, you need to. It's part of your normal, formula for achieving compliance. You want to make sure if you have pumps, incorporate VFDs. Make sure that you don't have fans and pumps and other equipment that isn't operating based on demand. You want to make sure that if you can, incorporate an energy recovery unit for your outdoor air supply system, right? You want to, if you're possible, what that does is it takes the exhaust, and again, many buildings are terribly unbalanced where they exhaust more air than they bring in. And that exhaust is treated air, right? The space has been heated. So you've spent money to heat it, yet you're exhausting it at a very high rate, and you're not capturing any of that lost heat and transferring it over to the incoming untreated air from outside. So there can be some significant reduction, particularly if you have hallway ventilation systems where you're supplying air to the building. The non-traditional or ECMs, right? You'll see these in certain buildings, but in many buildings they talk about it, but they often don't incorporate it, right? Cogen, these are combined heat and power systems, micro turbines, photovoltaics, wind turbines. These things are really kind of esoteric, and if you're still burning fossil fuels, it's not helping you, right? You need electrified systems. So we're really looking at VRF systems. We're looking at mini splits. We're looking at other systems that are relying on electricity. I mentioned operation and maintenance. Dennis mentioned it earlier. Really critical. You got to have an action plan in place for energy system maintenance and management in your building. I can tell you so little buildings have this. They may identify some basic maintenance functions, but very few are looked at it from an energy savings perspective. Those that do achieve significant savings, you really want to look at the state of those systems. That's why the capital plan is important, right? You're establishing what are the remaining useful life of that equipment. How do you maintain it and operate it so that you're not losing it and you're maximizing not losing energy and maximizing its life expectancy. You want to have preventative maintenance in place. I know preventative maintenance can cost, but nothing near the losses you otherwise get for when equipment either fails or is not operating the way it should. Monitoring procedures by your staff to make sure that they're looking at these on a daily basis, that they're submitting reports on the equipment at every board meeting. It's not just Susie's dog is barking in 3C. It's what are the equipment I have? This is my list of equipment. This is how it's operating. It's meeting our performance objectives, or it's leaking. It needs to be addressed. I have vacuum pump systems that are failing. I have this and that. How am I addressing that? And set those performance goals, right? This can be, you can get assistance from your engineer in figuring out what are those set points and goals that you need for maintenance functioning. Retro commissioning is a component under Local 87, but it's good whether I'm in a 26,000 square foot building or a 51,000 square foot building, you got to make sure those systems are commissioned, recommissioned, and retro commissioned as necessary to achieve proper performance. Set those energy reduction parameters. So in every capital improvement you do, you need to have a clear reduction parameter set. What am I doing this system for? What am I trying to achieve from an energy perspective? And where am I getting the reduction I need to get? And of course, your engineer, you want to hire an engineer who's going to put those plans and specs together, but it has to incorporate a testing, adjusting, and balancing component and a commissioning component, right? Because many buildings do upgrades and the contractor kind of does that. You need an independent person doing that who's really verifying that the system is operating the way it's supposed to, that those reduction parameters are being achieved, and you want an O&M plan to make sure it's going to keep being achieved, right? It's no good if it only lasts 3 months and then it goes back to prior settings that you had from your prior system that are not energy efficient. We mentioned the building energy exchange, looking at different reductions, looking at how your building's performing and what are the thresholds that are required. And the example on this slide, you can see this is a multifamily post-war building greater than 7 stories, and you can you get a sense of the size of it, how many tons that they used of carbon emissions that were the thresholds for them, sorry, for this building in 2024 and 2030. And you could see, like many buildings, 2024, you're fine, right? From the first class, we learned that only about 11% of buildings don't comply at this stage with the 2024 thresholds. But by 2030, majority of buildings don't comply. And how do we go about achieving that? Well, the fine may look only $15,000 a year. Well, after 5 years, that's 75 grand, and then it goes up in 2035, right? So you got to do something to address this. What can you do? You look at some of the things we've talked about. How do you get to, how do you get those different reductions needed to reduce your emissions below the threshold? The calculator is a great tool. It looks at benchmarking data that you've uploaded for your building. This is the website link. And what's great about this tool is that you can see on the left, and I'll refer this to Dennis as well, this type of utility endpoints, right? First is the top part is the type of building. In this case, it just says office, but it could be office, residential. It can be different inputs, right? Different uses. And it's based on the area, right? So you got to measure those buildings. Many buildings, what are you using? You're using information that could be outmoded or incorrect. Are you using Department of Finance records? Is that really accurate? So you really need to measure it, because that's going to set what the requirement is. So don't cheat yourself. And then utility inputs, right? These are based off the benchmarking. It's going to read what these values are for a particular building that have been inputted. Well, if you're still using oil, you can easily say, well, what's my equivalent gas? Take your gallons of oil, times it by 1.4, throw it into the therms, and then see what that reduction is. Again, oil to gas gives you something, but it's not a lot. It's often not enough. It's often, you're still using fossil fuels, so that you're still penalized for that. You want to obviously try to get more and more electric input from your system. But at least in the interim, it might be enough. Converting to gas from oil might give you time to then incorporate something more substantive with an electrification option. So it's very important to use this. Dennis, want to talk a little bit about this?
Yeah, I basically want to emphasize what you're saying. This is a really great tool that we use in looking at the different projects. And like you said, if you want to sub out, okay, we're going to convert our we're phasing out number 4 fuel oil as required by the law in the next 3 or 4 years. What's that going to do to our carbon footprint and our threshold in 2030 and 2034? You could change. What we found a few years ago is that a lot of the data in the benchmarking was really garbage, and that's because there was no ramifications for having bad data. Buildings were just adopting in 2009 when they first had to start benchmarking. They just took the Department of Finance number, which doesn't necessarily equal the gross floor area as required under the Local LL97 Climate Mobilization Act. It doesn't necessarily take in mechanical spaces, et cetera. And it doesn't, and the buildings all had just one use type. So plugging in the different use types, plugging and actually having them measured is very important. And you can look without being on the clock with the city. You can go and take a look at what the penalties will be, and what does it due to? Is it due to the Con Ed steam that the building is using? Is it due to the electric that the building is using? Is it due to the fuel, the natural gas or oil to heat the building? Again, using this source, please, if you take nothing else from these courses, go and look at this calculator. And again, it's a living document. It's something that you could use. I just checked this week, and I see that they've uploaded the most recent benchmarking information. So you have the most up-to-date calculator available and most up-to-date information. But but varying the different inputs and seeing what you can achieve by these different projects. It's a great tool.
Again, typical measurements, we had talked about some of these. For lighting, you want to reduce your lighting power density. You want to reduce plug loads for master switching, smart plugs, replace appliances with energy efficient ones, replace old elevators. Got a lot of buildings that still have old elevator or original elevator equipment. Domestic hot water, you're looking to install, again, low flow fixtures, perhaps a condensing gas boiler. Very good option if you have it, if it's for to give you time. Some of these condensing gas boilers are very, very efficient. BMS and EMS systems, controlling, feedback, really critical to seeing how your system operates. I mentioned ventilation. Sealing and balancing kitchen and toilet risers. Again, I go into so many buildings where they have poor ventilation, poor indoor quality. Fans are constant, speed. They're not adjustable. They don't have VFDs on them. They have maybe one outlet on a floor. Ventilation systems are a energy sink. Just really try to focus in on how to improve those systems. And of course, the envelope, for obvious reasons, windows, roof insulation, air sealing. Infiltration tends to be almost 50% of a building's heating load. So if you can improve on your envelope, you can get great savings available to you. This slide really just is an interesting one. It shows the resulting source EUI and greenhouse gas emissions for different pathways, right? And you can see these different pathways for, path 1 to path 4. And, obviously, path 4 being the best, if you will, and it kind of correlates to this bottom chart that shows that, the resulting emissions for both, current grid versus the cleaner grid, that, Dennis mentioned that in time you get better, for electrification options, you get better emissions factors or intensities in your calculation. But you can see here what kind of reductions are ultimately the range that's achievable from buildings that you'll see that may see more different, more reduction capability depending on the pathway they need to go. Not every building is going to have the same pathway, right? So this is just a graphic representation of 4 different pathways that owners could have achieved and what kind of reductions associated, or excuse me, what kind of source energy they were using for each of those pathways. And this is what really has to be analyzed. You have to analyze what works for you. And not every path is going to be, it's not a one-stop shop. Maybe path 1 is the best you can do for the first 10 years. And then after that, you can then develop or get enough investment that you need to opt something, a more significant pathway. So these are the types of ECMs that you would need to review. Some are fairly significant. And that's why an audit, and that's why reviewing this information now is so critical. A quick couple of case studies. This is one, it's a mixed use residential and commercial building. So it's almost 500,000 square feet, 29 floors, 315 units, so built 2005, right? So fairly new building, pretty large. We have, you can see from the right side, the energy use, it's, well, not quite 50-50, but uses a little bit more electricity than natural gas. Of course, the emissions is still, more on the electric side, which is what we want compared to natural gas. But there's still 36% natural gas, and that's something that hurts us in time. If you're looking at the 97 thresholds for 2024, you can see it's a little over 3,000, drops down to 1,485 by 2030. Again, because of the high electric use that they currently have. But again, when you do the analysis, you'll find that, well, for this building for 2024, their current emissions are 2,200. Okay, we're compliant. But by 2030, they're at 1,537. So they don't actually comply, and there's a penalty. It's about 13,000 a year. So over 5 years, that adds up to about 70,000. So what can we do? Well, we look at hot water, right? I mentioned that first. We have our existing hot gas heater. In this case, we had 1 out of 3 hot water heaters requiring replacement. So there's new, more efficient gas heaters, or heat pump water heater, right? That's an electric option. Heat pump water heater requires electrical upgrade and more space for installation, including an outdoor unit. So when you look at it, you're looking at, well, this is what the current usage is for these options. This is the total carbon emissions per year associated with each. What's the carbon savings associated with each? What's the penalty reduction of each during that period of time? And what the total then fee is. But then the big number is, what is that estimating cost, right? So you could see none of these are good, simple payback options, right? Cost is significant. Payback is nowhere near desirable. But I got to get my reduction. I got to get the greenhouse gas reduction somehow. And when you look at it from the prior slide and you're saying, well, I'm looking at the annual penalty compared to what my reduction is here, it's 1,000. That's not great. And then the heat pump water heater is a little over 5,000. Yeah, it's 5 times that. Still not great though, right? I'm still 8,000 short. So it's not an end all be all solution. This is going to could be part of the equation. The big thing that jumps out is in this analysis, you can see this 1.3 million to incorporate the heat pump water heater. You're saying, what are you putting in? Gold? No, it's just that the electrical upgrading needed to get this in to make it work. It was so significant that the cost is not great. Now, not every building's going to have a $1.3 million cost for this, because some buildings have enough electrical power to accommodate that upgrade. And that's what has to be reviewed. Now, there's going to be an energy incentives from the utility. There may be some other incentives available to reduce that cost. It could be tax incentives. But at the end of the day, you're going to have to, you're still paying a lot for what is a relatively modest reduction. So you're going to have to, in this particular case, maybe the hot water heater is not the ideal one. And that's something that's part of the analysis, right? As I said, it's not a one answer, one fits all kind of solution. It has to be evaluated carefully against all the other ECMs you're doing. Another case study, smaller building, right, a little over 30,000 square feet, 6 floors, 30 units, uses mostly number 4 oil. You can see even both pretty similar for energy use and emissions pertaining to oil use. The thresholds you can see are listed here for 2024 and 2030, right? 204 and 101 respectively. Current emissions are about 213. So the annual penalty for the first 5 years would be, somewhat a little over 2,000. After for 2030, 2034, 26,000. So that total penalty from 2024 to 2034 is a little over 140,000. So how am I mitigating that potential penalty? Well, let's look. There's electrification, right? What about 100% electrification? I have to upgrade the electrical service to the building. Maybe some solar panels, a heat pump water heater, putting in electric stoves, comprehensive electrical upgrade. That's like VRF or split systems. And again, parentheses, window replacement, we're not kind of factoring that in because in this case, there's no, it's shareholder driven. Well, yes, I incorporate all of these $2.2 million worth of upgrades. And you could see I'm getting pretty significant emission reductions and I comply. As a matter of fact, by 2030, I'm still less than what I would have had in 2050. But it took a significant investment. Now, most owners don't have the capability of investing in all this work, but maybe they do over time. And maybe it's you're incorporating it in a systematic way to try to reduce what that annual penalty would be. For a small building, 30 unit owners investing $2 million, that's quite an assessment. So you just got to factor that into the review and seeing what is the pattern, what kind of greenhouse gas reduction you're getting for the specific upgrade that you need to incorporate, and how does it work from you for 2024, 2030, 2034, and 2050. Again, it's having a short and long-term review towards compliance. I like this slide, not because it's tiny type and you can't read all these individual line items, but I like it because it compares two, right? One is upgrading the existing heating system, happens to be a steam system, traditional steam system in a building, compared to an HVAC system that incorporates VRF units. And what I like is that at this bottom, you can see, well, for the existing boiler replacement, it's about $412,000 for this size of building. It makes sense, right? You're upgrading your boiler plant. That's kind of what you would expect. It's gas fired versus VRF, right? Master, I got to run communicating piping, kind of copper. I got to put units on the roof, dunnage, units inside apartments. Various electrical upgrades, close to $1 million, right? 934,000. So you're looking at this sub cost and you're like, maybe I should just replace the boiler. But then you look at, well, there's some credits, right? You incorporate tax credits, in the Inflation Reduction Act and Con Edison's multifamily clean heat program. And you get some pretty significant reductions on the capital investment for the VRF. Yeah, you get nothing for the steam boiler. So you're looking at it and you're like, well, now it's 412 to 645. Well, it's getting closer. And then, of course, you got local law 97 penalties, right? Penalties because we're operating on fossil fuels, right? In this case, penalties were 2030 to 2034 period. It was about 15,000 a year. So that's another 75. And then after that, from 30, the next couple of years after 2035 to 2038, even more significant. Now, all of a sudden, by 2038, that VRF option didn't look so bad, did it? So the point is that this isn't, again, a case that applies to everything, but in this particular case, what often it looks like when you compare just the base cost as something that is clearly more financially desirable, when you start factoring in the availability of incentives and credits and the dreaded penalties that are set right now, it could change the calculus. So it's really critical that you review these in any local 97 capital upgrade consideration. Another case study, here's another multifamily building, a little over 300,000, 30 floors, 371 units. You can see the energy use, a lot of gas, a lot of natural gas, and the emissions reflect that. So when you look at the local 97 thresholds for 2024, 2030, a little over 2,500 to 1,200 for the requirements that you can't exceed. Current emissions in this case, you comply for 2024, but we do not comply for 2030, right? 14 to 39. So the annual penalty is around 57,000. Times it by 5, you get your 288,000 by 2034. So how do I try to address that? Well, in this case, this owner, they said, well, we're going to get rid of our number 6 oil at the time they had. They're going to convert to gas. We're going to decouple the domestic hot water system. Very important, right? If you can decouple it, provide a separate electrified domestic hot water system, you can achieve some nice savings. Elevator modernization. Again, a lot of elevators, old equipment, utilize, very inefficient motors or have a lot of losses. There's some real opportunities for savings in elevator equipment now. Lighting upgrades, they put in a cogen system. Not for the whole building, just satisfies some of the common area lighting, but also provides domestic hot water use, or perhaps heating water for a pool. If you have a facility with a pool that needs pool heating, heat pumps. In this case, heat pumps for pool heating, high efficiency AC units, and new rooftop fans. So they were able to reduce that penalty from 2030, 2034, right, from the 92,000 to 57 a year. And installation of a new control system to regulate the heating system, they thought they could save another 10 to 13,000 per year, and of course 25K on penalties. Ventilation system upgrade I mentioned earlier. So they want to incorporate fairly significant upgrade for the ventilation, right? They're estimating about 150,000, and right now their estimation is about 9.4% reduction in greenhouse gas emissions resulting from that. That a 5% reduction in greenhouse gas, right, about 60 tons, would be a reduction of about 16,000 a year. So the annual penalty would be expected to go down to about 16,000 after the energy management system and ventilation system is incorporated. So they started with individual upgrades and they're working towards it. It's not something that many owners can do at once, right? You got to start doing it systematically and making sure, through every capital improvement item that you have, where can you achieve these savings, and how do you get that, how do you get closer to compliance, and particularly at years 2030 to 2034 and beyond. The last case study I wanted to show was, this is a fairly large complex. Some of you are part of a larger complex. This is a 6-building complex. And they actually had significant damage from Hurricane Sandy. They actually had a heating plant that fed all 6 buildings. It was underground. It was completely flooded. So they needed not only to replace and upgrade their plant, they had to do a whole bunch of other upgrades and these buildings. They had to incorporate resiliency, which is a different component than energy efficiency, but in many cases you have complexes near water, near potential areas of flooding, and you really need to factor that into your designs. In this case, we did a whole series of different upgrades where incorporated lighting, electrical, air sealing, uh, radiator valves, high efficiency gas boilers in each building above design flood elevation, system control sensors. And we were able to get these types, these were the estimates. And again, this was done by Stephen Winters they were the energy consultant for this particular complex. And we were the design engineer for the capital work. And you could see fairly significant savings for electrical, fuel, total site energy savings was calculated, and that greenhouse gas emissions was fairly significant. So the annual penalty reduction was quite large. And this slide kind of in that same case study shows all the different upgrades, the investment that was made in those upgrades, and the implementation costs. In this case, the paybacks were pretty significant. And you can see just from the right, payback period really reduces down to just a few years for these larger complexes, where you're able to incorporate a whole series of the moderate and deep recommend ECMs because of the local 97 penalty savings factored in, right? Before 2019, that gray area was never considered, and now you have to consider it. So Dennis, I think that kind of concludes our thing. We have, you maybe want to talk a little bit before of some alternate compliance pathways before we finish up.
A little bit. I'm sure it's going to be touched on in the other seminars,
Yeah.
but the good faith efforts rules that recently came out, it's really kicking the can down the road, and it's really just for the first compliance period of 2024 to 2029, in which you can delay complying with the carbon emissions cap in 2024, 2025, but you still have to meet them by 2026, and you need to submit a full decarbonization plan, which, as a result of just looking at this entire seminar, it would be difficult, if not impossible, for the vast majority of buildings. So the good faith efforts option to mitigate your penalties in the first compliance period has limited utility. Really just trying to get all of our boards to look at this and reduce their carbon emissions overall to avoid the penalties.
Do you see many building owners considering this? I mean, most of our clients are not really looking into renewable energy credits. I mean, obviously, if you're in a larger complex where you have your own way to generate electricity on site, you can maybe take benefit to this.
Yeah, those are the buildings that it would be applicable to more. The renewable energy credit rules that we've seen to date only allow for the electric component carbon coefficients to be addressed by the RECs, and they also have to be Tier 4 RECs for renewables that are generated within New York City. So you can't have an offshore wind farm and buy green energy there and have it comply with your local 97 penalties. So unless those rules change, there's going to be very limited availability, and there's not much of a market yet for the greenhouse gas offsets. And you touched on the distributed energy resource a little bit earlier. Generating and storing electricity at a location. Sure, that's great if you have the the facilities to do it. You have a big enough roof, if you can install solar, put in some batteries. But the real best way to comply is, of course, these retrofits, which are not easy and not cheap.
Right. I think that's the thing that many of our clients are faced with is establishing in their capital plan what emissions reductions they can incorporate with the specific capital improvement they need to implement based on their typical life cycle of a particular system. So, whether it's a roof, windows, exterior walls, boilers, heating generation, again, most of our clients tend to have common heating systems, but individualized air conditioning systems. Others have air conditioning systems where the largest load is during the summer. and they have fairly significant, loads during that period of time that they have to mitigate. Other factors that you have to consider is if you're in a mixed use building, often you'll find that the residential component of that building is actually fairly energy efficient and fairly compliant. It's the tenancies, the community facilities, commercial units connected to it that may have their own systems that do not help a particular owner at all, that they are, using gas or using fossil fuels or using, systems that are hurting them in terms of potential penalties. Because again, this is all, whole building calculation, right? You're not able to, even though you can do your audit and you can determine relatively accurately what the percentage of energy use and greenhouse gas emission is occurring from each of those tenancies. The question is, well, how do you improve that? And as a board, I wonder, how do you address that? It's if you're facing a fairly significant penalty either by 2024, 2030 as a result of those different tenancies, and maybe one or two tenants are using a bulk of energy, and even though they represent a sliver of the actual square footage of that building, how do you address it? Especially if you're in a condominium where that's owned by somebody else. Those are kind of considerations that we haven't navigated yet, and we're still trying to figure out how best to approach it.
Yeah, I have seen a number of co-ops that do own the space and lease it out to either retail or other users. In renewing those leases, they're trying to put in clauses that put the carbon emission penalties on the tenant for their use. So if they're a high energy user, such as a supermarket, yes, they have a higher coefficient and everything, but if they're going to be using not only do they have to pay for their own electric and gas usage, but they should also cover the penalties. None of this was contemplated where 10, 15 years ago when these leases originally came up, but they should always be considered now. If you're leasing space out to any of these users, certainly talk to your council about putting in clauses.
I think that's it for us. That's our 90 minutes. If you had a question that we weren't able to get to in the Q&A, we will respond to it.
Thank you guys so much for somehow cramming this into 90 minutes. I don't know how you did it. And thank you for answering all of the questions, Dennis and Jeshnu. Thank you. Thank you for your help there. We do have questions remaining, which I'll forward to you guys, and we'll try and get everybody answers to. I think that's it for tonight. If everybody could please take the exit poll so that we can figure out the breakout rooms or put suggestions if there are other things you'd like to see next session as well, that would be great. And thank you. Night.
Thank you, everyone.
Thank you.
Have a good
Night.
night.
Take care, everyone.